All right, today the kind of section that we're going to graph is known as the ellipse. And the ellipse has a standard form that I want to let you guys know. It's very similar to a circle, with a few distinct characteristics to it. So I'm going to go through the standard forms of what an ellipse looks like, and there's two of them. So the first standard form that I want you guys to know, all right, so I'm going to go ahead and I'm going to write standard form. Is this x minus h squared all over a squared, okay, plus y minus k squared all over b squared, and it's going to equal 1. So this is the first standard form that I want you guys to recognize, okay? And in this standard form, the important things that you're going to have to go ahead and you're going to have to take out of here is you're going to have to take out the center. And the center is obviously going to be at h comma k. All right, so your center point is h comma k, okay? You're also going to have to take out your vertices. And in this one, for your vertices, that is going to be a positive and negative a comma 0. And your co-vertices in this one, in this standard form, all right, are going to be 0 comma plus or minus b. Okay? Now, the second standard form that I want to show you is pretty similar. It's x minus h squared, all right? And then you got y minus k squared is equal to 1. Except this time, instead of having the a squared underneath your x, you have b squared, and you have a squared over here, okay? The center, no different this time. Your center is still at h comma k. This time, however, your vertices, all right, your vertices are going to be 0 comma plus or minus a, and your co-vertices are going to be, so your co-vertices are going to be plus or, let me extend this page a little bit, are going to be plus or minus b comma 0. Okay, and we'll go through here what each of these look like. So let's go through and let's start graphing this, okay? So this right here is an ellipse. It has x squared over 49 plus y squared over 36, and it's equal to 1. And this is one of the big things that you see right here, equals 1, that kind of deciphers what a circle is versus what an ellipse is. But let's identify the important things here. So we want to identify my center point to start with. Okay, so the center is h comma k. Now you'll notice right here, this is almost the same as saying x minus 0 squared. So my center is actually going to be 0 comma 0 because there's nothing with my y variable either. Okay, now I think it's very important that we have a squared down here and we have b squared here. So let's identify this number. We're going to identify it as a. So I'm going to take the square root of 49, which is going to give me 7. I'm going to take the square root of 36, so my b is equal to 6. Now, according to this one right here, my a value is 7. It goes with this standard form right here, standard form number 1. Okay? So let's go ahead and let's identify what my vertices are. So for my vertices here, all right, you just go ahead and you start at the center. And if your a value is 7 and it's right here underneath your x, I would go 7 to the right, and I would also go 7 to the left. Okay? So my vertices are going to have an ordered pair of 7 comma 0 and negative 7 comma 0. My co-vertices, okay, so I have my co-vertices here. They are going to be a b value of 6. I would go up 6, and I would go down 6, and my co-vertices would be 0 comma 6 and 0 comma negative 6. Okay, and now you have these points to go ahead and graph your ellipse. So I'm going to go ahead and show you exactly what that's going to look like. I'm going to start right down here in this corner, and I'm going to make my ellipse here. Okay, another thing that I want to show you about the ellipse, all right, this, from vertice to vertice, this right here, this is known as your major axis, okay? And you'll notice your major axis starts at 7 goes to 0. So that's a distance of 7 right there, and it's a distance of 7 this way. So your major axis is 14 units, or really it's just double whatever your A value is, okay? Your minor axis, that one in this example goes up and down, so that's your minor axis. And in this example, your minor axis is equal to 12 units long. And that's really just taking and doubling your B value. It's 6 here and 6 here. So your minor axis connects your co-vertices, and your major axis goes ahead and it connects your vertices. Okay? So that's standard form number 1. Let's skip to slide 2 here. All right? And let's take a look at example number 4 here. All right? You'll notice, for example number 4, we do have a lot going on here. All right? Let's start by identifying my center. Okay? What is with your x here? Well, it's a positive 1, so we're going to actually take out a negative 1. And you have nothing with your 0, so you have a center of negative 1 comma 0. Okay? Now, in this one, you have 25 underneath your x. You have 49 as the denominator underneath your y squared. This time, this is your a squared variable right here. So if you take the square root of this, you have a is equal to 7 here. Take the square root of this, b is equal to 5. So the larger number is always your a value. Wherever that's at, you're going to go ahead and use that as your a. Okay? So what I have now is I have from my center point, I am going to go ahead and move with my y's now up 7, down 7. So my vertices, all right, this time my vertices are going to be negative 1 comma positive 7 and negative 1 comma negative 7. Okay? My co-vertices, when I took the square root of my b value, it was equal to 5. So my co-vertices, I'm going to go 1, 2, 3, 4, 5. And I'm going to go 1, 2, 3, 4, 5. So that's going to be an ordered pair of 4, comma 0. And you also have negative 6, comma 0. Let's construct my ellipse using those 4 points. I'm going to come down to this corner right here. And I'm going to draw in my ellipse. Now you'll notice, this one, instead of like our first example, in our first example, this one was stretched horizontally, okay, because your a value is with your x's there. This one is stretched vertically. So I want you to recognize now that your major axis this time, it's going to run up and down. So this time your major axis of 14 units is a horizontal axis, which means then that if that's your major axis, your minor axis runs horizontally. So that right there is going to be your minor axis, and that minor axis is, what does it come out to be, 10 units? You go 5, you go 5, yep. So that's graphing ellipses, okay? Now, writing the equation of ellipses in standard form. Now remember, standard form, x minus h squared over a squared plus y minus k squared over b squared is equal to 1. All right, this is the important part here, equals 1. So to take and turn this into standard form, what I would actually do to turn this into 1 is I'd divide this by 225. I'd divide this by 225, and I would divide this by 225. Okay? And when you do that, you go ahead and you kind of take out 225. So if you go ahead and you divide that, you end up with, let's scratch that example. Look, do me a favor. Change this right here to 9. Okay? That's going to make it nicer for us. So if we do 225 divided by 9, all right, we end up with x squared over 9. All right. Plus, we do 225 and 25 together. We end up with we end up with 9, so I get y squared, all right, over 9. This one right here, 225 divided by 9, that should have been 25. That's my bad, guys. So this right here should be 25. Okay? And now this is equal to 1 here. So now it's in standard form. All right? Important stuff that comes out of here, your center. All right, your center for this one, 0, 0. So your center is going to be at 0, comma 0. Okay, your A value right here, 25, square root of that is 5, and your B value is equal to square root of that, which is 3. So from that, you should be able to identify that your vertices are going to be at 5, comma 0, and negative 5, comma 0. And you should be able to identify that your co-vertices are 0, comma 3, 0, comma negative 3. So this would lead to your major axis, okay? And then this right here would lead to your minor axis. So this one, as you notice, is stretched, all right? It's stretched horizontally instead of vertically, okay? So let's take a look at this one. Let's turn it into standard form. You want that to be 1, so I'm going to divide everything through by 100, okay? So this right here, we're going to end up with x squared over 4. We're going to end up with y squared over 25 is equal to 1, okay? Now this one, you'll notice, look at what happened. Your larger value, your a value now, is your a squared is underneath your y squared. So this one, you're going to have a stretch where your major axis is stretched vertically, okay? But this one right here is in standard form now. Okay, let's move on. Use information provided to write in standard form. Center, all right? So the center is h, comma, k. Your vertex goes with your x here. So you know that your a is equal to 14, and you know that your co-vertex, your b, is equal to 10. Okay? Now this one, you'll notice your vertex goes with your x value, so that you know when you write this one, you're going to have x squared over a squared, all right, plus y squared over b squared is equal to 1. And it's really easy for this one because your h and your k, you have x minus 0 squared plus y minus 0 squared. And then you have to take it underneath here. I got to square this value. So we do 14 squared, which is going to go ahead and give us 196, right? And we do 10 squared, which is going to give us 100, and it's all equal to 1. To simplify this right now, x squared over 196 plus y squared over 100 is equal to 1. Okay, so that's how you take that given information and go ahead and write the equation of a line there. Okay? Not the equation of a line, the equation of a ellipse. All right. Now this one, you'll notice, is not in standard form at all. Okay, we have 1, 2, 3, 4, 5 terms here, and we need to take and turn it into an ellipse. So here's my suggestion. I would take my x, all right, my x variables, x squared minus 6x. I would organize those together. X squared plus 6x, all right, done with that, done with that. I would then take my y variables, and I would put those together. So I have x squared, all right, and then I got 4y squared minus 80y, all right, and then I would take this, and I would move it that way by subtracting it. So I got equals negative 309, okay? Now, just like we learned the other day, all right, we want to turn it into x minus h squared. So what we need to do is we need to complete the square inside this set of parentheses. So I'm going to cut this in half, 3. I'm going to square it, and I'm going to put a plus 9 here, which means I'm also going to go ahead and plus 9 right here. Okay? All right, so I'm going to complete the square there. Now, this one you could do a couple different ways. Here's how I like doing it. Let me rewrite this now. X squared plus 6x plus 9. I am actually going to take, and I'm going to get this 4 out of here. I'm going to divide out a greatest common factor. I'm going to have y squared minus 20y, and I'm still going to leave my blank there. All right, and it goes ahead and it equals negative 309, and then you have plus the original 9 from this completing the square. Now, to complete this square, cut the negative 20 in half, which gives you negative 10. And you're going to go ahead and you're going to square negative 10. So you got negative 10 times negative 10. You're going to put plus 100 right here. Now here comes the trick, though. We're not just going to go ahead and add 100 here. That actually should be 4 times as big as 100. If you distribute that in, you're left with 400 here. Okay? So now look at what we have. I'm going to write it all in red. This simplifies to be x plus 3 squared. Okay? This right here simplifies to be plus 4, and then you have it times y minus 10 squared, and it equals, and if you add all of this up, this is a plus 9 here, you're going to end up with 100 on this side. Now, if we want to turn it into an ellipse, we're going to take and divide this by 100, which means you take and divide this by 100, which means you take and divide this by 100. Okay? Now, this one we can leave as is. X plus 3 squared, right, over 100. Now, you'll notice in this one, the 4 into 100, all right? If you go ahead and you do that, you have y minus 10 squared over 25, and it equals 1. Okay? What is in this example, your center point? All right, your center is going to be at negative 3, because you have your h value, and it's going to be at positive 10. So that's your center value. Now, in this one, if you take the square root of this, your a is equal to 10, and your b is equal to 5. So if I ask you about your vertices, okay, if I asked you about your vertices, you would go ahead and you know your a value is 10. So I would add 10 to this number right here, to my x value, which would give me 7, comma 10. And then I'd also subtract 10 from this, which would go ahead and give me negative 13, comma 10. So that right there, guys, would be your vertices. And your major axis would be a length of 20 because you double that. Okay? Your co-vertices here, all right, you have a b value of 5. So you're going to take this number, and you're going to add and subtract 5 to it. So you got negative 3, all right? If you add 5 to it, you got 15. And if you subtract 5 from it, you end up with 5. And this right here would be the important info that comes out of that standard form. Okay? That really, guys, is how to go ahead and graph ellipses as we did up here, all right, at the beginning, all right? And also it shows you guys how to take these equations and turn them into standard form for what an ellipse should actually look like, okay? We'll continue tomorrow with graphing hyperbolas, and we also need to get in graphing parabolas as well.